that Sn equal to 1 plus 1 by 2 plus 1 by 3 up to 1 by n is not convergent. How to show this? We assume that this is convergent, and then we use the Cauchy's general principle of convergence, and then we get the contradiction on this. This is how we are going to prove this. So let's first assume that, if possible, the sequence Sn is convergent. And if the sequence is convergent, then by Cauchy's general principle of convergence, for epsilon equal to 1/2, there exists a positive integer m, such that the mod of Sn minus Sm is strictly less than epsilon, that is equal to 1/2. So it is strictly less than 1 by 2. For all n greater than equal to m. Now if I take the value of n to be twice of m, then this n is strictly greater than m. Yes. So for n equal to 2m, we have n to be strictly greater than m. Mod of s of n minus s of m. Here we have taken n to be twice of m. So writing this s2m. Mod of s2m minus sm. What is Sn given to us? It is 1 plus 1/2 plus 1 by 3 up to 1 by n. Substituting n equal to 2m, we get 1 plus 1/2 plus 1 by 3 plus 1 by 4 up to, this is 1 divided by 2m, minus Sm. For Sm we replace n with m. So we have again 1 plus 1 by 2 plus 1 by 3 up to so on 1 by m, and the mod. So this is equal to mod of, in the first bracket we have 1 plus 1 by 2 plus 1 by 3 up to so on 1 by m. Then 1 by m plus 1 plus 1 by m plus 2 and reaching 1 divided by 2m, or m plus m, right? Minus, in the second bracket we have 1 plus 1 by 2 plus 1 by 3 up to 1 by m. So up to 1 by m, all the terms cancelled out. And we will be having in the mod 1 divided by m plus 1 plus 1 divided by m plus 2 up to 1 divided by 2m can be written as m plus m. Now because m plus 1 is strictly greater than m, if I take the reciprocal of this, this will be less than 1 by m. Yes. So can I write that this 1 divided by m plus 1 is now strictly less than 1 by m? Now because your m is a positive integer, right? Which means the mod of these terms is as it is. So writing the terms without the mod, because m is a positive integer, up to 1 divided by m plus m. Very fine, alright. Now we know that m plus 1 is strictly less than m plus m. Can I write like this? Yes. If I add this 1 to m, this will be less than adding m to m, right? M is a positive integer. But for m equal to 1, we get here an equality, right? So except 1, m plus 1 is strictly less than m plus m, where m is a positive integer, right? So if I take the reciprocal of this, I will be getting 1 divided by m plus 1 to be 1 divided by m plus m, right? So can I write this further as, this first term is greater than 1 divided by m plus m. Similarly, the next one, it is also greater than 1 divided by m plus m, up to so on, and writing the last term as it is. So this is equal to 1 divided by 2m plus 1 divided by 2m up to 1 divided by 2m. How many number of terms these are? 1, 2 up to m. So these are m number of terms. So this sum is further equal to m times 1 divided by 2m. So cancelling this m and we get here 1 divided by 2. So we are getting the mod of s2m minus sm to be greater than this sign, greater than 1 divided by 2. Or originally we can write this as mod of Sn minus Sm is greater than 1 by 2, which contradicts this inequality for all n greater than equal to m. And for n strictly greater than m, we are getting the contradiction. So hence this inequality contradicts. Let me mark this as 1. So it contradicts 1, right? So our supposition was wrong. What we have supposed that Sn is convergent. So our supposition was wrong. Hence, the given sequence is convergent. So we have shown this result by a contradiction by the use of Cauchy's general principle of convergence. Alright, thank you.